So how a microcontroller identifies the input is the question. I am giving some input means how a controller or processor. So whenever I say controller means it meaning is processor. That means it is not only 8051. It is Intel Core Duo, Intel Quad Core, or it can be AMD. There is nothing like for 8051 can understand the input like this. ARM can understand input like this. Intel Core i5 can understand input like this. Whatever we speak, it is common for all. Intel Core i5 or the processor working in NASA, processor working in Pentagon, processors working in Australia, processor working in US Embassy, whatever you say. So it is common because they are all digital programmable devices. So through 8051, we are experimenting. The same thing will happen in all the systems. So from this answer, interrupt is not necessary to understand the input. To give an input, always interrupt is not necessary, is the answer. Okay. He is saying code conversion. Through code conversion, the content of the data memory can be brought out in a user-friendly way from the microcontroller to the external world. For an output, this is comfortable. But the question here is how a microcontroller identifies the input. I am giving input means how the processor will understand. In our case, we know very well processor means what? Your ALU, your program counter, your instruction, that's all. There is no brain, there is no sensing system available in the processor saying that, okay, something like that. It is a machine. The question here is how the machine can identify you are giving some input is the question. So just visualize and tell. Okay, program is our brain. Some program has to identify something is happening outside. Some program has to identify something is happening outside. Fantastic, right? Okay, that's the clue. Okay, through program we can provide the input. How through program we can provide the input? Whenever we write the program, it is happening only within the memory. Okay, through program we can give the input. That is what we are doing so far. This answer is valid answer. Yes, sir. We have stored some 2 in the data memory location. We have stored 4 in the data memory location. From 2, this 2 enters the processor from the data memory to the processor. This 4 enters the data memory to the processor. And processor adds this 2 plus 4 equal to 6 and it comes out. That is valid answer, 100% correct. That input is coming from the memory to the processor. But what I am telling is outside the microcontroller to the microcontroller is the question. So what your statement is correct, there is an input to the processor from data memory. One thing you have to understand, right? Instructions are fetched from the program memory. Based on the instruction, if the instruction needs data are read from the data memory. Please try to understand. You must not use the word in opposite way. Instructions are fetched, data are read written. Data should not be fetched. Data fetching it's a major mistake. Instruction read it's a major mistake. Instruction need to be fetched from the program memory to the flash, program memory to the instruction register. It has to be decoded, it has to be executed. Fetching, decoding, execution must happen. You look at the data sheet of the data memory. So this is the data memory. Keep on saying, right? 0, 0 to 7F is one set of data memory. The right hand side is special function register. This is rewrite memory. Here you can see both the program memory and data memory. So this is both program memory and data memory. Okay. So in the left hand side, it is read only. It is given as program memory as read only. All our flash, all our opcodes are present in the internal flash memory. 0000 memory location is there in the bottom. You can see now because we have made the EA pin as 1. What is EA? External access pin. In your microcontroller, it is a 31st pin. Look at the circuit diagram. You look at the 31st pin. Look at the 31st pin. Try to find out the 31st pin. So pin number is not here, right? You can see the external access bar VPP, the top left corner. Look at the circuit diagram. The top left corner, the 31st pin is connected to the VCC. Okay, so this 31st pin is connected to the supply voltage. We are ensuring that we are using the internal flash memory. We are not using any external memory, something like that. So the program that what we write, it is entering into the flash memory. So that is also you need to understand. Okay. So here I am telling one statement, right? Whenever you are learning any integrated circuits, it is mandatory for us to look at the data sheet. Once again I repeat, whenever you learn any IC, any integrated circuits, it is mandatory for us to look at the data sheet. whenever you want to understand any kit, it is mandatory for us to look at the user manual or circuit schematic. So now we are looking at the user manual or circuit schematic of the kit that what we have in front of us. Okay. So who will give the circuit schematic? The manufacturer should give the circuit schematic, which you can download from the ALS Electro, where they have provided this data. Which data? Circuit interfacing data. So your PCB board, where you have a microcontroller which is connected with all the peripherals based on this circuit. That is now. So 31st pin is connected to VCC and 18th and 19th pin are connected to, say for example, 12 MHz crystal. Okay. Then you have a reset key circuit and the rest of the thing is correct. Okay. Coming to the code, right? So program are fetched, decoded, executed, data is read from the data memory and written back to the data memory. So that's why data memory is rewritable. That's why all variables will occupy the data memory space. So input to the processor from the memory as this statement is correct. But my question here is how the microcontroller identifies the input. Microcontroller means entire 7 microprocessor, ROM, RAM, parallel port, serial port, timer, interrupt controller all put together from the outside is the question. Now, any guess? Data can enter the microprocessor or microcontroller through port. According to our discussion, your program is entering the flash memory through SPI port. Program is entering the flash memory through SPI port, serial peripheral interface port. Correct or not? Because if you look at the pin diagram, go to the datasheet pin diagram, I'll show you. There is a protocol called, there is a serial port called SPI, which is called a serial peripheral interface. So if it is an SPI, means there are 4 wires, right? Master out, slave in, MOSI, master in, slave out, MISO, and serial clock, SCLK. So this is the 3 pins associated with SPI. Look at the pin diagram of the datasheet. Here you can see 6th pin, 7th pin and 8th pin of AT89S52. So the microcontroller that what we have in our kit is called as AT89S52 microcontroller. The S denotes it is in-system programming facility. That means it is programmable through SPI port. So what are the SPI pins? P, 1.5, 1.6 and 1.7 of AT89S52 microcontroller contains MOSI, MISO and serial clock. That is master out, slave in, master in, slave out and serial clock. So through these 3 pins, the hexadecimal file from the PC is entering the flash memory of your microcontroller. Okay, this is programming. Once again, you have to classify programming is different from communication. This is something like giving birth to the microcontroller, right? It is an intelligence which we are flashing into the flash memory. This is not read-writable, it is programming, right? So, but to support him, data can enter the processor through the port, serial port. Through port only data can come in, through port can be, data can go out. Okay, you are more or less correct. Can you give some more possibilities? Data can enter through the port. That's what we keep on saying that, right? Port is a place where exchange of goods takes place between 2 different medium. One is land medium and water medium. Correct or not? So similarly, why the name port here? Exchange of data takes place between 2 different medium, internal digital medium and external medium. So data enters through ports. So ports are broadly classified into parallel port and serial port. Okay. Here data can enter through port. Here we have 4 parallel ports. Port 0, port 1, port 2 and port 3. So data can enter through 4 parallel ports if it is a byte data. If it is a byte data, 22, 33, 44, no, byte data. If it is a byte data means it can enter port 0, port 1, port 2, port 3. If it is a bit data, it can enter through P1.0. It can enter through P1.1. If it is a bit data, because we are talking about control, right? Control means on and off. Switch on the bulb means on, off. So 1, 0. 1, 0 has to come through port 1.0, something like this. Correct or not? So, more or less, his statement is 100% correct. Appreciations. So, other than ports, there is no other way in the world. Whatever processors which was invented so far, whatever processors and controller which people are going to invent in the near future, Processor can accept the data. There is no other way to make the data to enter this. Another justification here is you have a laptop, you are connecting your input device called mouse through USB port. So input is going through the port. You are connecting this laptop to the keyboard, external keyboard through USB port again. If you are communicating with the external world through Wi-Fi or Bluetooth, something like this. So Wi-Fi is a port, Bluetooth is a port. Only through port you are exchanging the data. There is no other way to give in the data to the microcontroller, only through ports. So serial port and parallel port. In the parallel port, bit level entry as well as byte level entry. Bit level entry as well as byte level entry. Okay, more or less, we are almost done. Once again, the same question. How your microcontroller identifies the input? When I switch on the bulb, bulb has to glow. When I switch off the bulb, bulb should not glow. That is what expected. Correct or not? So that is electrical system. There is no intelligence there. You are making the circuit, you are breaking the circuit with respect to the tube light. There is no intelligence. You are short circuiting and you are open circuit. You are making the contact, you are breaking the contact. Making the current to flow, breaking the current to flow. So when the current flows, bulb glows. When the current stops, bulb will not glow. It is just make and break. There is no intelligence. But here, how a controller identifies, I am pressing the switch. எப்படி வச்சுக்கலாமா? நான் சுவிட்ச் அமுத்துறேன் அப்படின்னு கண்ட்ரோலருக்கு எப்படி தெரியும்? சுவிட்ச் எங்கேயோ வெளியே இருக்குது அப்படி வச்சுக்கலாம். Now that is the question. Hope you understand. I am pressing some switch. How a microcontroller, as you rightly said, how the microcontroller program will understand. நான் அந்த பக்கம் வெளியில ஒரு பட்டன் அமுத்துறேன்னு உள்ள இருக்கிற ப்ரோக்ராம் எப்படி தெரிஞ்சுக்கும்? Voltage to the corresponding pin. What voltage to the corresponding pin? You are almost done. Yes, it is related to voltage. How a microcontroller identifies the input? Again, question. Already all are one because all are pulled up. That is why all the LEDs are glowing. Whether you have written the program or whether you have not written the program, moment you connect your kit, all the LEDs are glowing. If you connect port 0 with LED, why? Because all are pulled up. Several times it has been told, all the 4 ports are pulled up. Already it is one. When you press the switch, it becomes one means pressing the switch have no impact, right? Already it is one. When you press the switch, if it is one means how your controller will identify I am pressing the switch. Oh, if I press the switch, oh, the input port will become, the corresponding bit will become 0. அப்படி சொல்றீங்க. Okay. 100% correct answer. Appreciations. So, we are keep on talking about microprocessors and microcontrollers are digital programmable device. When we say they are all digital programmable device, there are only 4 possibilities, sir. The pin can be in logic 1 state, number 1. Pin can be in logic 0 state. 2 possibilities are there. The other 2 possibilities are pin can transition from 1 to 0. Third option. Fourth option, there may be a transition from 0 to 1. In digital electronics, they have clearly studied this as level interrupts, level triggered interrupts and edge triggered interrupts. As long as it is 1, it is level 1. As long as it is 0, it is level 0. These are the 2 states of a binary. So it can be 1 or it can be 0. That means it can be level 1 or it can be level 0. This is level triggered interrupt, something like that. Level 1 triggered interrupt, level 0 type of interrupt, something like that. 2 options. Other 2 options are edge. There may be falling edge. It can transition from 1 to 0 or it can transition from 0 to 1. So there are 2 possibilities. Transition from 1 to 0 is called as falling edge. Transition from 0 to 1 is called as rising edge. Other than these 4 possibilities, there is no other possibilities in the world for any microcontrollers in the world. Starting from 8051 to the Qualcomm Snapdragon. Because it is digital, only these 4 things can possible. It can be 1 or it can be 0 or it can make a transition from 1 to 0 or it can make a transition from 0 to 1. How a microcontroller identifies the transition? Fantastic, sir. That's all, sir. His statement comes back again. அப்போ jump bit அப்படின்னு சொல்லி அங்கேயே இருக்கு வச்சிடலாமா? Assembly. Jump bit loop 1. Make the code to jump to the same loop. So when you press the switch, as he rightly said, 1 will become 0. Assuming if 1 becomes 0 when I press the switch, the corresponding bit will become 0. As long as there is a bit, it will be there. When there is no bit, means it will come down and do the increment. Let us assume I am pressing the volume up button in a TV remote control for convenience because everyone can visualize just like that immediately. That's why I'm bringing volume up button. Already the volume is 22. When I press the up button, it will become 23. So already 22 plus 1. So if there is no bit means come down and increment this, something like that you can say. So the moral of the story is all the microcontrollers identifies the input by looking at the transition in the pin. All the microcontrollers identifies the input by looking at the transition in the pin. In our case, already the pin are in logic 1 state at reset condition. The only possibility is produce a transition from 1 to 0 in such a way that microcontroller can understand. So the mechanical arrangement of the switch must be done in such a way that when I press the switch, it has to produce some transition. Controller will understand I am pressing the switch. You are doing some mechanical action for grounding the pin. When I press the switch, it will be grounded. When it grounded, that pin will become 0. When that becomes 0, internal code, jump bit in assembly language case, maybe we are going to write the C program. If switch 1 equal to 0, much more meaningful, much more user friendliness, then you can do this. Okay, I'll write a program and I'll make you to understand. Okay, so the circuit diagram, connector number 9. Look at the screen, look at this screen please. Here you can see the connector number 9 is connected to 4 switches. So look at this, one end of the switch is connected to grounding. Look at the screen, one end of the switch is connected to the ground. Maybe you can show it in the cursor or somewhere. So one end of the switch is connected to the ground. All the 4 switches, one end is connected to the ground. Other end of the switch is connected to the 4 pins. Where we can connect to any one of the port. Option is given to the user. So if you connect the connector 9, that is 1, 2, 3, 4, any one of this, say for example 1 to 40 means 0.0 means, for example 2.0 means, default it will be in logic 1 state. When I press the button, what will happen? That logic 1 will be grounded through the switch. So the pin will also become 0. When it becomes 0, inside your code will identify. If the pin becomes 0, do this. Something like that. We could have written the code. We'll work on that. I will justify that by doing that. Just listen. We'll make it happen, right? I hope you understand the concepts. This is the concept way of understanding. Our level 1 is over. Now let me do the simulation, which is level 2. But all must focus here. Then later on you can do. Okay. Understanding is the prime requirement. Go to the code. So in the code already we are blinking. So what we can do? Now switch amutna is blink down on the marriage. If it is all without any control, it is keep on blinking. Now we can plan something. When you press the switch, it has to blink. Or as long as I am pressing and holding the switch, it has to blink. When I leave the switch, it should stop blinking. Something like that we are assuming because already we are in this track. Just by adding few things to this code, much more comfortness. So what to do? Yesterday itself we have understood yes bit set reasonable, right? Yes bit in the second line. Switch 1 equal to, because we are interested in switch 1, right? As we switch 1, SW1, SW1 equal to P2.0, P2 power 0. Okay, so as he rightly said, checking for 0 in the pin, avladhan. You have to check for 0 in the pin. When it is 0, do the necessary things, avladhan. Appo, while 1 we are bringing in some condition. Default is blinking, but now we are bringing in some condition. What is the condition? If switch 1 equal to 0, blink the LED. If not, just leave it. So if statement, we are bringing in if statement for meeting our application requirement. So if switch 1 equal to 0, port 0 equal to 1's complement of port 0, and the delay for persistent sufficient. The 11th line கடைசியில போய் enter கொடுத்துட்டோம்னா ஒரு fulfill ஆகும். ஓகே, ஸோ இன்னொரு டேப் கொடுத்துட்டு இங்கே வந்து சாட்டிஸ்ஃபை ஆகும். 13-14 லைன்ல ஒரு அலைவ் பண்ணணும்ல. It's fantastic, right? So this is the simple code, right? So only if the switch 1 equal to 0, what is switch 1? Switch 1 is a label for P2.0. When 2.0 becomes 0, the condition is true, the if statement is true, then it will come inside the loop, it will keep on blinking. How long it will blink? As long as switch 1 equal to 0. When you release the finger from the switch, it will become 1. When it becomes 1, the condition fails, so LED will stop blinking. Let us simulate this first, then we will test it in the hardware. compile, build, fortunate, 0 error, 0 warning, go to the debug start stuff. We simulate it. The second module, right? எல்லாரும் கவனம் இங்க இருக்கணும் நிறைய டைம் சொல்லியாச்சுங்க உங்களுக்குன்னு ஒரு வாய்ப்பு கொடுக்கப்படும் சொல்லியாச்சு make me not to do any mistake if I did without any mistake then same thing you can also try so simply you run the code port 0 and port 2 both the ports are available now port 0 is not blinking so far it was blinking but now it is not blinking why because the condition fails because P 2.0 is logic 1 now. You can see P 2.0 is logic 1, so it is not blinking, right? So by pressing the switch, what will happen? P 2.0 will become 0. That we are simulating it now by making the pin as 0. அவங்க என்ன தப்பு பண்ணியிருக்காங்க அப்படின்னா latchல போய் பண்ணிட்டாங்க ரொம்ப இன்ட்ரெஸ்டா அது latchல மாத்தக்கூடாது இந்த ஃபர்ஸ்ட் ரோ வந்து மைக்ரோ கண்ட்ரோலர் உள்ள இருக்கிற ஃபிளிப் ஃப்ளாப் செகண்ட் ரோல இருக்கிறது தான் நம்மளுடைய பின் so all our things must happen only in the second row. So if you must do that in the second row. P 2.0, the second row LSB. Run the code, and in the second row, she has done it correctly now. The pin is made 0 purposefully, meaning that when I press the switch, 2.0 becomes 0. Because it becomes 0, LED is blinking. As long as it is 0, LED is blinking. When you release the hand, due to the spring action, the key will come up. So it will become open circuit. Already it is pulled up, it will become logic 1. So the condition fails, it will not blink. Okay. Just start 2.0, 2.0, make it as 1. 2.0, make it as 1. Why you are making 2.1 as 1? 2.0, make it as 1. And 2.0 is 1, it is not blinking. When 2.0 is 0, 4.0 is blinking. When the switch is 1, it is blinking. Sorry, when the switch is 0, it is blinking. When switch is 1, it is not blinking. Simulated. Software testing is over. Coming to the hardware. Simply, when you download it, it will happen. So what to do with the hardware? Already we have connected port 0 with LED. Already it is done. Only thing is take a single wire and connect P 2.0. There is bottom right corner of the switch must be connected to the 4 switches. There are 4 switches in the board. You have to connect it to one of the switch. And download the code and then press that button. As long as you press and hold that button, LED will blink. When you release that button, LED will not blink. This is how a microcontroller identifies the input. This is fantastic, right? Let me demonstrate until you just wait and let us do that. Now it is getting downloaded in the kit. We are experimenting that in the kit. In the simulation it is working fine. We are very eager to see the same outputs in the hardware kit. Let us do that and let us see how best it works. When I release the switch, LED is off. When I press the switch, LED is blinking. When I release the switch, LED is off. So as long as I am pressing and holding the switch, LED is not blinking. When I release the switch, LED is off blinking. Now much more control over my controller. I can able to give the input, I can do the processing, I can get the output. Correct. Oh, I have done 2 projects. One project is junction mounting system. 5 minutes before I have done the project, I have solved the project. After 5 minutes, I have done a security system. This will be, I will keep the switch in front of the thing. Instead of LED, I will connect the buzzer. If LED blinks, if people are not aware of blinking means, if the buzzer buzzes means, people will become alert. So LED க்கு ஒரு buzzer connect பண்ணிக்குவேன். அப்போ அந்த மேனேஜர் தெரியாம இப்படி பட்டன் அமுத்திட்டாருன்னா ஏதாவது பயந்துட்டாருன்னா பட்டன் அமுத்திக்கலாம் இல்ல கால்ல வச்சுக்கலாம் press this button to inform that PC in front of me save me அப்படிங்கிறார் junction warning system which is blinking as an LED correct traffic light controller oh that's all by using some delay independently switching on and switching off LED traffic light controller then here it is bank alert system or whatever you call now the 2-wheeler or 4-wheeler indicator left indicator போட்டா left LED right indicator போட்டா right LED பண்ணலாமா now we are going to do 2-wheeler left indicator right indicator system out of 8 LEDs 4 LEDs we can keep it for the left indicator other 4 LEDs we can keep it for the right indicator now we are using one switch let us use one switch for left indicator switch let us use another switch for right indicator switch When I press this switch, this 4 LED has to blink. When I press the other switch, this 4 LED has to blink. Something like that we can do, which will be much more interesting, right? Okay, so how to modify the code? Go to the tail LED, LIS left indicator switch, LIS RIS left indicator switch, right indicator switch equal to P2.2.3. LIR equal to 0. Just look at the screen, which is very important, right? LIR equal to 0. If left indicator switch is 0, port 0 equal to 0x F0. Port 0 equal to 0x F0. The left side LED has to blink. Left side 4 LED has to blink. After a delay, the 16th line, port 0 equal to 00 and delay. Port 0 equal to F0, then port 0 equal to 0x00, then delay of 50,000. So, that's all for left indicator. 12th line to 18th line, copy and paste it. If RIS equal to 0, port 0 equal to 0F. Fantastic. That's all. Compile, build, rebuild all. For testing in the hardware, we have to simulate for convenience. Let us do the simulation and come. Then we go to the hardware. Let us do the simulation and we go to the hardware. Okay, run the code. Run the code. So let us press 2.0. Left LED is blinking. Left 4 LEDs are blinking. Let us press 2.3. Okay, the dancing is doing break dance because he has pressed both the switches, right? So he has to release that switch, right? Now right LED is blinking. Suppose I am going straight up in the all the 8 LEDs will go. Then left switch, left 4 LED, right switch, right 4 LED. Fantastic, right? The simulation is over. Testing it in hardware. What to do? Already one switch is connected to P2.0. Another switch has to be connected to P2.3. That alone we have to do it in the hardware. If so, we can see the vehicle indicator in the prototype. So this is called development board. The development of vehicle indicator system is being done in the hardware prototype. Proof of concept of vehicle indicator system is being done. Something like that we can say. So code is getting downloaded. Code got downloaded. We are pressing one switch, right? We are pressing one switch. So left indicator switch. So left 4 LEDs are blinking. We are pressing left indicator switch. So left 4 LEDs are blinking. Pressing left indicator switch. Left 4 LEDs are blinking. Now I am pressing the right indicator switch. Right indicator LEDs are blinking. So left indicator, left LEDs are blinking. Right indicator, right LEDs are blinking. Pressing both. The program is written in sequence. Left LED is blinking, right LED is blinking. So practically this is not all. So left indicator, so left LEDs are blinking. Pressing right indicator, so right LEDs are blinking. So vehicle indicator system is tested. Okay, that's all. This is how we can give the input. We can give the output as per our convenience. Now we can try now. That's all.